for all of our folks in Portland, Seattle, Silicon Valley, Boston, and Vancouver, of course. All right. Well, let's go ahead and dive into it. So nice to see everybody. We'll get into the course logistics in a moment, but I wanted to start with something that's relatively famous in the game development community or game development sphere. And it's a particular file format for how data is stored. It's called the WAD format, sort of as a joke, because if you have a WAD or a collection of stuff, the folks who came up with this thought it was funny, but the format's called Where's All the Data? And this is actually the format for the game Doom, which we looked at a little bit ago. It's maybe the first class or the second one as well, talking about id Software and how they store their data. And again, the big deal with these WAD format was, well, this was how the game was stored, each different level. And it's actually a quite simple, but also a clever data format. And then folks would modify this, again, using this file format to change the behavior of the game, because a game engine, again, is something that's a data-oriented framework. So you can play around with this. I played around with it a little bit. There's an online tool here you can actually click on if you want. And then if you want, you can download this Doom file here. There's a free version. So let me see if I can find that file here. Here it is. And then you can actually look at all the different information that's encoded in there. So all the different things that exist, which is kind of neat here. Let's see, what are these? So the different maps and so on. So it's kind of cool, all the different data that can be stored there. So I'll let you play around with that later on in class if you'd like. But for now, let's go ahead and dive into things here in our recording. So just a few logistics. Again, your assignment 2 will be due shortly, so later on this week. As of this recording, it's the 24th, and I have it on the course map as the 27th for the due date. So let's just go ahead and check that out, see where we're at. Again, already in week number 3 here as we're moving along here, but that's just on your assignment 2. So just keep an eye on that. I know office hours are going on. There's even office hours going on as we speak, I believe. So do feel free to reach out for help, sooner than later for these assignments. Otherwise, your assignment 3 has been pushed to your repository, and I'd encourage folks to get started on that. There'll be another 2 parts, and I'll talk about that throughout the course lecture today. So let me pause here for a moment for our folks who are live. Any questions about the course or things going on? Right. Not hearing anything. If there are, just let me know, and then we'll take care of them as they come up here. So with that said, I'll go ahead and give us a little bit of a recap of what we were working on last time. So last lecture really was our introduction to SDL, what will be our sort of low-level graphics framework, as well as our library for handling things like input. And I've already seen a lot of folks through assignment 2, which has been great, looking at things like font libraries that work with SDL and so on. Which isn't required, but again, that's great to see folks digging in there. So make sure that you're trying out those examples. I mean, you're certainly going to be using this for your assignment 2 as you build the Pong game. But with SDL, then, once we sort of understood how to handle input, we could continue working on our main game loop and actually handle things like keyboard presses, mouse clicks, and so on. And then ultimately, this started helping us look at our main game loop again as this data structure or rather pattern, I guess, in a game where we have to keep track of the frame rate. 60 frames per second is ideal. And again, if we have different machines, be able to move our objects at a predictable speed. So that was sort of the frame independent update we talked about. And then there was a little bit of an optional review on C++ at the end if folks dove into the slides at the end. And again, I'd encourage you just to really take advantage of those resources if you're, struggling with C++. Again, we're not trying to do anything complicated with the language now, but, today there'll be some new stuff. So, every day just do a little bit of review, and again, it'll serve you well for learning a new language here. So that's what we were working on last time. So far in this course, at this point, you've implemented 2 games. The first one being very simple. Well, if we want to call it a game or interactive story or whatever we want, that's the idea. But you're working on completing a Pong game, so that's quite nice. So I'm expecting folks will have something like this. But as we're moving forward here with building our games here. Just looking at this game, we have, 2 paddles, the ball, maybe some text for the score, or maybe you're outputting this in the console, that's fine, and a net in the middle here. There aren't too many assets, meaning too many, images or fonts or things that we're loading, but we are going to start to want to think about that because a game does consist of lots of different pieces. So that's what we're going to be talking about today. For the majority of this actual module here, we're going to be talking about resource managers. So looking at from the Game Engine Architecture book, this diagram here, we want to figure out what are the things that make up a game and how do we manage them. So, we'll have a resource manager for our different game assets. The music, the artwork, whether 2D or 3D, the fonts, the data files, etc. And you can kind of see resource manager here encapsulates, again, each of these separate resources. We're primarily going to talk about images today, but that's the idea. So, just going back a little bit and thinking about creating resources in a game, and I know some folks have experience with this, idea of creating different resources, and that means different things depending on what your specialty is in the game industry, right? We have sound folks, which is even much more different than music folks, or even the narrative designers, of course, images and 3D and so on. These are all the different, many different components that make up a 2D or a 3D game. And the assets that we create, again, are usually from some external tool. And you'll often see this abbreviated as DCC for Digital Content Creation tool here. We're going to use those tools, write some code. We put the code together with the art, and that's a game for what we're making here. So just to give you familiar with some of these tools that you might want to explore, and again, some of you based off the first survey have some experience. Right, there's different sound and music tools. From GarageBand, if you're on Mac, you might be familiar with, or Audacity or Ableton, all these different sort of sound creation tools that generate .ogg or .mp3 files. And even these different file formats, again, if we want to get into it, have different trade-offs, but that's the idea here. Something that's quite popular, and maybe for folks who have done some Unity, maybe you've played around with Fmod. Again, that's another little plugin or API for working with sound data. On the image creation side, we've got tools like Photoshop or GIMP or Paint. And then there's actually a lot of other sort of pixel art creation tools out there that you can use as well. And the big idea here is that from these image creation tools, you're just getting a bitmap image or a PNG. .exr, again, is a special format where you can get higher color ranges, so less compressed images if you really need some detail. So just a few things to think about. JPEG, sort of a compressed format, so it's not as good for games. It's great for the web, but for games we want high quality, right? The art matters to our users. As far as the video and movie assets go, there's various tools that could render the actual, if you have a 3D movie or something, or a cutscene in a game, that can be done in most of the high production 3D tools, as well as more often you'll even see integrated into the engine some cinematic tools. So just something to kind of be aware of. A lot of post-processing could be done in tools like Adobe After Effects as well. And then here's just a note on the different 3D tools. There's a huge collection of these days. Blender 3D is the big free one. If anybody comes and takes graphics with me later on, or has, you know that I make you learn a little bit of 3D modeling, or at least get some exposure to it. But this is the idea, to store the actual geometry in one of these formats. That could be just the geometry or the animation data and so on. So, the big takeaway with knowing some of those tools as an engine programmer is, one, you might end up, working with some of the folks who are artists and just work in those tools. And then it's sort of your job to figure out, well, how do I work with this external tool? Maybe it's a Blender 3D or something like that, and get the actual geometry into a format that our engine understands. And that's the digital content creation pipeline. Okay, so that's the idea. I actually know quite a folks. This is a good actual entry into the sort of industry to be able to build sort of tools for 3D, modeling software or Photoshop, and kind of massage or transform the data in a way that an engine like a Unity or Unreal can understand. So that's just something to keep in mind there. Because again, these exporters, they're not perfect. And I mean the exporters meaning from a Maya 3D or a Photoshop or these tools. So we often have on the game engine side a way to sort of, they call it a compiler, but it's really just a resource compiler that maybe transforms or translates the data in a certain way that our engine understands. The best example I can give you is sort of towards the middle here, since we're doing 2D work primarily in this class, is, we'll primarily be working with red, green, and blue images with those channels, red, green, and blue. The 24 stands for 8 bits per channel, so 1 byte of information each. But there's all sorts of color formats that some of these tools like Photoshop or GIMP might prefer. And you can see all the different combinations or how many bits some of these formats use. Again, just kind of depends on what art tool you're using. So that's just sort of an example that, again, these assets might have to go through a resource compiler and get them ready in a way that's most efficient for your game engine or the platform that you're developing for. Again, developing for a PC is much more different than how you might compile the assets for a PlayStation, for instance. But the end story of that is, once you have your data in the correct format, then it can run as efficiently as possible without any other processing. Okay, so you can look at some of these tools again, as I mentioned, a Blender 3D or your favorite 2D tool, and just kind of look at the documentation, see what their format is. I think that might be an interesting insight to have. But kind of, making this a full circle and thinking about some of our asset management here. Just wanted to kind of note some of the other things that are important to know when it comes to game development. We as programmers, which is, everybody taking this course is, identifying at least in some way as a programmer. It might not be your only skill, of course, or your primarily one, but most of us use Git for storing our code. Git is actually not a great tool for storing lots of large images or binary data or so on, because the repository can get quite big, even if you move one piece of data in an image. So it's one of the weaknesses of Git. So it's just something to be aware that game industry will either use their own tools. So Unreal Engine, I've got an older version of Unreal 3 here, but 4 is the same. That might manage its assets or have a version control system built in. I think Unity has the equivalent that's gone quite a ways. Has anybody in my Vancouver audience heard of Perforce by chance? No, that's just another one. Maybe I'll make an empty slide for it, and maybe I talk about it a little bit later in the course, I suppose. But I'll just let me just make an empty slide here, just so it's available. Perforce is a more popular tool in games. Works a little bit differently for how it manages the assets, but and it's actually in some ways easier to use than Git. You kind of just put a lock on a file and say, I own it, and nobody else can touch it. But it's kind of a neat tool. But just anyway, to continue on with that thread though, of just managing assets, and I think this gives a better picture. This is from Naughty Dog, which is the popular studio. We'll talk about that Jason Gregory, the author of the Game Engine Architecture book, works at, and is in Santa Monica, California. But they basically built this tool here where you can see all the assets on the left side of the window. And then you're basically able to download a version of those assets when you build the game, and use different versions of even the art assets. So just something to think about, these tools, the amount of data that you're working with that must be processed. So that's just a little bit of an insight as far as the game assets go. But where are we in this course right now? Well, we're doing something like this. We're learning about SDL here, where we're loading in individual images. So again, maybe in the Pong example, we have the paddle, the ball, the net, maybe a font, maybe some other images if you're doing something. Maybe another paddle or something. So maybe not 100 images. I don't know. We'll see what your folks' Pong games look like. But this is the basic idea here for loading our resources. So the question is it that simple? And it might be, but I want to give you at least a little bit of a file system review. And as far as loading files goes, just to get everyone on the same page, the first thing that you have to know when you're loading your files here, and let me go back here, is we want to use relative paths. So that means, relative to where our assignment 2 directory is, paddle.bmp, or let me just directly illustrate this here and make this a font. We'd maybe want to use /assets/ paddle.bmp. That's relative to the current directory that I'm in, versus something like /home/mike/assignment2. Unfortunately, if you distribute, or if I distribute this to you folks, you're probably not Mike. In fact, I know you're not me, but you probably have a different name or file structure or whatever. So, if you try to play my game and I give you this path to an asset, it's not going to find it. So again, that's why we prefer relative paths. You've probably seen this in the other programming, but it's worth noting because, well, I always see this, I guess. So that's why. So we do have to kind of keep track of that, right? Prefer relative paths so that we can get to things. Now, of course, there's navigating your file system a little bit. But the other thing to keep in mind is, again, even with those relative paths, which is relatively simple, Linux and Mac folks usually use a / here. Windows, unfortunately, changed the direction of that slash. So when you're loading your files, you might have to change the direction, depending on how good your load function is. But then, PlayStation might look something like this, right? We have /dev, and then here's the hard drive. Versus Windows always, or I shouldn't say always, but much of the time has the C: drive. So you kind of just have to know or pick up some of these things as you go on. But the main thing is just making sure you have a relative file path. That's the main thing I got to emphasize for folks, so that your code actually compiles on someone else's machine. The other thing to keep in mind, and it's just sort of a note down towards the bottom here, is that it is important when you're developing software, especially games, to make sure that you're testing on a variety of systems. Now, that might not be realistic for us here, although I just want to develop it or give you some insight that, when you deploy a game, there's going to be lots of different systems. So if you're always developing on your super high-end, desktop machine, your customers might not actually have that type of machine. So, if you're getting 60 frames per second consistently, they might not, depending on how good your hardware is. So it's worth testing on, the type of machine, or even developing on the type of machine that you actually want to deploy to. There's a couple famous developers who are known for that, and I'll bring it up again when it's relevant when we talk about performance. So speaking at just a high level here, we know about the file system. If I go back here and this idea of paths and, where our hard drives are and some of these things, but how do we sort of interact with that is the next question. And that's where the file system comes into mind here. Or rather the API here. So, how do we manipulate file names or move in paths in our code, open and close files, read and write, maybe handle things in a little bit more of an optimized way, meaning asynchronously, which I'll talk about at a later date. But these are the basic functionalities that we want to be able to do, right? Open and close a file. And that's essentially what SDL is helping us behind the scenes, right? Just loading a bitmap or a texture resource. We do have to think about this, and it's quite common at larger studios where you'll have programmers just working on the file system API, the engine, which is kind of funny, trying to optimize things. And here's sort of a reason here. And, I wonder if give folks in Vancouver a chance to think about this. It's an article from a few years ago. I think it's always true, but why do games have bad loading times? Why are we always waiting to play? Any guesses from folks?
Loading the content from the disk to the memory.
Yeah, right. That's gonna take some time, right? In our file system. Sometimes that's network data too, so we have to wait a long time across a network. And maybe it's just poorly programmed sometimes too. So it's a combination of all those things. And the situation isn't, at least in the foreseeable future, maybe we'll see in the next few years. There's a reason I haven't had to update this slide for a while. It's because they've also got this sort of problem here, where our hard disks, even if it's a solid state drive, this is still true. This is the old sort of hard drive with a spinning wheel on it. But even with a solid state drive, the reality is how fast and how quickly we can access data on something like this versus on our graphics card, where we're able to load lots and lots and lots more data these days, and it's scaling up exponentially, versus how fast we can access the data is much more of a linear function. So memory is actually the problem here, as you folks mentioned and said, we can't access our content right from the developers in the game fast enough. We can display a lot of it very fast on our graphics card, but loading it's still the bottleneck. In the case of a regular hard drive, you literally have a physical moving device looking for content. So that's a major sort of bottleneck. We're going to talk a little bit about memory in some future modules for folks who have taken some systems classes. That might refresh you a little bit as well. Again, here's the issue, right? We look at a detailed model like this, looks really nice, but the reality is this art asset here is probably 40 or 50 megabytes at least, several million or at least several thousands of triangles on all the individual points here, and then all the different textures, coloring in the detail. It takes quite a long time to load this, and this is just one character or maybe even just one model in a game. So again, these things take time here. And folks don't like to wait for loading screens. So you can see the very first search, someone said, I want some games with very few or no loading screens. Okay. Well, we got to give the customer what they want, I suppose. So when it comes to loading data here, there's a couple different strategies we have here, meaning buffered, and maybe you have some intuition on this, or again, if you've taken systems, of course, you'll understand, but buffered is sort of when you want to move some data and sort of stream it in. I guess, is a way to say, but to bring it in large blocks of data versus unbuffered, which is just kind of saying, as the data comes in one at a time, give me each byte here. So that's sort of the idea. So just briefly, and again, these will be functions that you're familiar with. And in C++, the only difference is you can put standard in front of these and call the C operations. We'll actually sort of prefer the C file input-output library because it's a little bit lighter weight. But we might also, for those folks who dug into it, or I think I've already shown you how to use fstream and some of these things, but these are your basic operations for opening, closing, reading and writing files, and so on. I won't dive too much into it because we also have an SDL, a file input-output library as well. And again, we might prefer to use this throughout this course because it's more cross-platform. It handles some of the tiny details that are different between different architectures. So just something to keep in mind here. And for fun, if you're on Linux, you can actually see the cost of every operation that you do if you're just printing what's actually going on here. This is the advantage here of having a buffered call here where you maybe call the print function here 1, 2, 3, 4, 5, 6 times here. But when you actually write out the data, you'll actually find that there's only one write operation here where you can see the HELLO and then the end-line character. And these little type of optimization are things that we are going to want to care about at some point. And that's much different than if this was 6 different calls, right? We can think of this as 6 times faster. Maybe it's 6 times faster, but it's at least 6 times fewer operations. So that's just a note there. All right. So, I mean, with that little review of opening and closing files and some of the stuff you do, what's exactly the problem here with this recap and sort of understanding where our data comes from? Well, potentially there's a lot of potential for waste here when we're loading this data. And I've kind of highlighted it here. And again, it's not always obvious, but if you notice, I'm loading my image 1. I've got my paddle here for our Pong game. Then I come back here and I load it again. Maybe this is the left paddle, maybe this is the right paddle. And if it's truly the same data, they're both these bitmap images here. Well, if I'm loading the same thing twice, that's wasteful. And it kind of even gets worse because this is just the pixel data. And then maybe I'm even generating the same texture twice as well. So now I'm wasting memory on my CPU when I load the pixels. And then as we learned a texture, which is on the GPU, I'm wasting memory there. So that's no good either. So that's sort of the problem here that we want to tackle. So, I can kind of run this example. This is actually what we're going to be doing for our next homework. This is our running example for today. How do we fix this problem so that we only load one resource at a time and manage our resources properly? So for that, we need to create a resource manager class here. All right, so what is this? A resource manager? Well, it's something that sits on top of the file system. So again, we're not going to rely just on the C library to load files only one time for us. We've got to actually implement this. There's nothing built in for us. And we want to manage our different types of resources. So images, textures, 3D models, music, sound files, fonts, etc. And make sure that, as we're managing our files, we're utilizing our very precious memory as efficiently as possible. Because again, memory is a scarce resource. Even it appears not to be, but in games, it really is. That's really where we lose our performance. And we kind of want to even think about this like on a phone or something if our games are going to run there. So we have to be very cognizant or very, very aware of how important that is. So what exactly is the responsibility of this resource manager? Or you could call it an asset manager or media manager. Well, it's really got two jobs, to load resources, and again, at the proper time. So that could mean during a load screen, or maybe there's a clever way to do it while the game's actually running. And then we've got to unload resources. So I've got to be sure that, if we have a duplicate resource, we're not unloading it if it's still being used. So that's really it. That's its two jobs: to sit on top of our files that we load and make sure that we load our resources efficiently. Okay. So if our resource manager sits on top of a file system, it's going to wrap the file system functionality. And I might have mentioned this, but maybe just as a recap. And there's actually a few other reasons. Can folks kind of think about why that might be? Why would we want to wrap, the ability to open and close a file and some of those things? And SDL is going to help us with this, but
to encapsulate in the file system API, so you can like more arrow prone to just make it encapsulation so you can easy to use and.
Yeah, all those things, I think. So making it easier to use, right? So we don't have to, understand all the different flags and writing files, right? To work with the different APIs, different platforms, right? Is it a Windows, machine with a different facing backslash, or is it a PlayStation or whatever? So all those things, right? We want the cross-platform capability, and we want control, over how this works, right? We're going to encapsulate our behavior. So let's look into this a little bit more here, and maybe I'll, pause for a little activity here, and for folks, what resources do folks see here? You can just kind of call some out. What are the different things or entities that you might identify?
Image. Texture.
Pig, yeah, texture. What else?
Water.
Cloud. That'd be material, the clouds. Yep, some more geometry. Yeah, all the pigs. Movement. Hope I didn't catch the last one.
Lighting.
Oh, the lighting. Yep. Yeah. So the actual scene here. There's got to be some lights. There's a camera, right, revealing into the scene. So there's quite a few resources, and most of those were probably loading from a file, right? Even things like maybe the camera configuration, where the lights are placed, the materials for the water, right? There's tons of stuff here, right? The geometry. But there is a finite, right? As far as folks were looking at this, you didn't say, well, one dirt block number one, dirt block two, grass block, number one, grass two, So it's not quite this, right? We sort of identify what the unique resources are, and then some of them get reused, right? We've got one 3D pig model, and here's the second one of it, but it's the same copy. There's nothing really different there. So it's not quite this here. So again, that's going to be the goal of our resource manager that we set up, to just make sure that we're loading exactly one of these resources here. Because, again, that's just a little bit more efficient, that these resources can be shared amongst the other objects. So it's the same piece of memory. It's the same data that we'll be able to refer to. Whether it's this tree texture or the grass texture or whatever, that's the case here. Now, again, it might not always be true if we have some entity that's maybe a little bit more dynamic. Maybe it's been destroyed or upgraded in some. But generally speaking, a 3D cube is always a 3D cube. So we only really need to load one copy of that. So just nice little exercise there. So, the second job of our resource manager, again, managing the resources, is, for us to think about because we have all these different assets here, I've got, just listed a few here, the paddle, the ball, the net, maybe the fonts or whatever. We want to be able to handle this relatively efficient. And this actually goes back, you can think about this from our pre-class warm-up, but ideally, instead of having all these individual files in a directory, we would have something like this, just load resource archive, and then whatever that bundle of resources is. All right, and that bundle might be, it's sort of like whenever you download something from the internet, you just get a .zip file and just send away one file. Or in game engines, they come up with like .pk3, which is just abbreviation for package, and then 3 is the version of that file format. But why do folks think we want to use a zip file? Why would we prefer to load from a zip file instead of all these individual images?
Because zip file is smaller. Is it faster to read from zip?
Yeah, right. So we're using our file system, right? It's, as far as the computer is concerned, right? It's just bytes, but we know zip file is compressed, so that is less bytes to read. We'll have to do the work of decompressing it later, but that might be an okay trade-off. Yeah, go ahead.
And also we can just let our hardware just write once. We don't need to write multiple times.
Yeah, right. It's just one block that we're reading, right? One, load read archive, and just load the one file. That makes things kind of nice and easy for us here. So this will be something we'll eventually add into our assignment here. And it's a really important kind of detail to be able to load that data fast, as you folks said here. Right, so I'll probably end up using zip unless I find something simpler, but it's sort of a popular open format. As you folks mentioned, right, this is compressed, so less data. So again, whether you're downloading assets in a game or just loading them from your file system, if you already have them, that's much quicker. So we like that. It's also organizationally, just passing around a zip file is easier than downloading a bunch of individual files. Get kind of messy. And it's sort of easy to version them too. You could have maybe you have the French version of the game versus the English or whatever. And you can kind of compartmentalize the resources a little bit better, right? And you can have zips of zip files to sort of exchange stuff. And then to the last point, as folks mentioned, just doing the one read is pretty important with the .zip file. Every individual file that you have on your operating system, so every photo you've taken or whatever, it creates additional metadata as well, which takes up space. So again, that's just another bottleneck that we don't need in our engines, right? So if we can compress stuff and just have one file without all the metadata of what directory does this file live in, what's the file name, when was that modified, et cetera, we can do without. Again, that's probably less of a problem in terms of storage these days, but it still is something we want to optimize for. So with that said, for each of our resources that we load, we need some, unique identifier for them. For us, for the purpose of this assignment, it's going to be enough to just have the file name. But typically, you would come up with some globally unique identifier. Sometimes folks pronounce this as a GUID, if you ever hear that term. And usually that's just a way to generate some unique name so that I know that this is, if I go back a few slides, that this is the 3D model for the pig versus the texture for the tree versus the water, right? I need some way to uniquely identify those resources. So that's what we're going to sort of keep in mind. So keeping that in mind, if I have some unique way to identify a resource, like again a 3D model or a texture or some image data, and I want to be able to guarantee only one of those resources has been loaded into memory, what kind of data structures come to folks' mind that they might use? That might be an efficient way to look up and see, hey, is this resource already been loaded? What comes to folks' mind?
Hash map.
Yeah, I hear hash map, and I'll accept hash map or any of the alternate hash map, hash table, dictionary, all the same thing. My book, are roughly the same thing, right? Underlying, implementation might be a little bit different. And in C++, we have an implementation called a map or unordered map. And I'm going to, I'll give you enough hints for your assignment that those are the two to look at. And you can look at the differences between map and unordered map performance-wise. But yeah, that's exactly right. We want sort of our key to be some globally unique identifier. In the case of a file path, that'll be unique enough for us for this assignment, but as we proceed forward, we'll want some way to hash those and create a unique ID. All right. And then this is just a little aside here that, regardless of the files that we're loading or the file types, all we really care about is the pixel data. So, we would typically have our own format in our engine rather than using PNG or JPEGs. We might have, whatever the name of your engine is, image format. All right. So anyways, and this is a little bit of a rhetorical question, so I don't really need an answer, but it's something that we do have to think about. And it's, how long does a resource actually live once it's loaded? So, meaning, do I just load everything from a giant zip file when the game's created and then just kind of keep it forever? Or what about the order that I load the resources in, if that matters? So that could be impacted by your data structure, that underlying hash map to see how it's working. Then we'll also think a little bit about, if the resources, are they being stored in video memory or main memory here? So it is something that we have to think about. And sorry for the walls of text today. We'll look at some code a little bit here. Again, we have to just figure out from the resource manager's perspective, when do we load the resource? For us, it'll be fine for the purpose of our assignment. That's as the user says, hey, load, resource, that's when we'll bring in everything. And we'll want to just keep it alive until the user explicitly says, unload resource or remove resource. That's fine. But the challenge is, is basically just to say, well, is this resource being used in 2 or more places? If it is, then you can't fully get rid of it quite yet. Okay, so that's the idea here. So with our resource manager, and I'll get to design pattern at the end, we do want to sort of explicitly manage how it's initialized and shut down, or how we create and destroy resources. Okay, so again, we'll want to imagine some sort of data structure, that sort of manages the loading of our resource manager. We'll talk about this in a little bit. This will probably be the follow-up assignment or one a little after, where we might want to be able to load a resource asynchronously, or sort of stream it in to be a little bit more efficient for us to think about. And additionally, per resource, we can even think about, for those of you folks who listen to Spotify or music on YouTube, do we need to load the entire chunk of data, or just the current bytes that matter? So this is kind of true of do we need to load the entire soundtrack of our game, all the music, or can we just read 4 kilobytes at a time as the music's playing? So that's the difference between streaming in a resource and just loading the full data. So we'll look at this in the future. We may make it as a homework assignment, but I'll certainly be talking about asynchronously, loading in resources. So with that said, for our live group here, let me just kind of rewind here. I know this has been a little bit of a wall of a text today to set the stage, but any questions on some of the things that we're thinking about with resources or as you're loading in data in the game? Let me go back. this is our sort of running example, thinking about this code that might get written that we want to avoid. All right, I'm not hearing anything from our live audience here, so why don't we take a 10-minute break? You can flip through the slides, stretch your legs a little bit, and then we'll resume in 10 minutes here.
我没做，我什么都没做。你要干嘛？你要干什么？你要干嘛？我什么都没做，我只是睡着而已，他就自己做了。
I want to put some logo. Just here. He's a spoiled baby, so he just gets broken. He's scared, you know? And yeah, in the second shot, he's so cute. It's like lure him with some fruit here. Yeah, treat. Let's do it. Let's do it. Let's do it. Oh, see? Oh, nothing. Did it again. just that's all. Don't do it. It doesn't painful. Oh my god. Let me hear it. Just that's all. So it doesn't hurt too much, but he's like,
exactly.
he's acting like that. So we'll feel sorry for him. Oh my god, this is cute.
有那个 puppy，那个 therapy 的，一堆人围着那只狗。我看了一下。
Wanna go? You sure?
Yeah, you can stay here.
No, just.
All right, we'll get started here in a moment, folks. Just give the other folks a moment to join us.
I actually have a question.
Sure, go for it.
Slide 54. It's saying we have load resource archive bundle. Is that a SDL function or just a?
Yeah, this is just a example. This would be something that we would implement ourselves here.
I see.
Now there are libraries. In particular, there's a zip library and a zlib library that will allow you to just kind of open and basically do this same type of thing here to unzip all the data, and then to explore, essentially explore the zip file as well and pull out the resources you need. Yep. Yeah, this is what we'll want eventually to create. Other questions any folks have on this resource manager or the idea of what we're going to start approaching here? If not, yeah, let's go ahead and proceed here then. All right, so we took a look at resources, kind of their importance and maybe some motivation here. But how are we actually going to program this thing? So this is what I want to start looking at now is the actual pattern here. So we got to look for our first pattern, and maybe some of you folks have looked at this already, or maybe you've seen this in other classes too, singleton pattern in particular. But this is the first pattern from the game programming patterns book that we're going to look at and use or apply in our game engines here. So just briefly, what is a design pattern? Sort of my definition of it, I suppose. It's a solution to a problem that shows up over and over again. So there's enough of a common pattern that these things can be named. And one of the ones that we want to be familiar with again is singleton. That's one of the sort of most popular ones here. And then the other thing to know about design patterns is they're not perfect. They're pretty good templates for solving a problem, but they come with trade-offs. So we will want to identify some of these trade-offs here. So what's the singleton? I'll just start with this one. A singleton is a way that we create objects in our C++ code, but we ensure that a class has only one instance, and exactly one instance. So that's the idea of a singleton here. And the advantage that we get with a singleton, since we just have exactly one instance of the object, is that we have a global point of access to it. So again, that could be a sort of something for you to think about, but then we're able to access this class anywhere in our code. It's effectively a global variable. So you can take with that what you know about global variables, if they're good or bad, or what the trade-offs are. But here's some examples. Let me see if I can actually make this a little bit big, folks, since I can see your screen. I'm wondering if you have a hard time reading it, but the basic example is, if you have a game configuration class, that's probably a good, there's probably a good chance you only need one of those in your game when it's running, right? Figuring out what the window size is, what graphics card you're using, these types, language you're playing the game in, these types of things here. So that might be a candidate for a singleton itself. It just sort of naturally fits. It's possible too, depending on how you structure a game, if you only have one character, maybe one hero, that could be a singleton. We'd have to think a little bit more about that, but that's sort of by design, you only have one, hero in your game, that could be fine. But sort of a more universal example, since we're talking about resources and so on, is file system. So that's one single point of entry. And for most of you folks, right, on your laptops, you probably have one hard drive and one sort of organization of all of your files. So that's sort of a singleton itself by design. And it's something that's globally accessible. So, let's take a little bit of a look at some of the code here. And this is the actual design pattern for a singleton. Now, you'll be implementing this in your assignment, a singleton for your resource manager. So they all kind of look the same. They could be implemented a little bit differently, but just looking at some of the C++, let's kind of decipher what's going on here. And this is, again, taken directly from the Game Programming's pattern book, which I'll encourage everyone to read before the assignment. But, here's the quick note, or the thing that's interesting is, for this class here called file system, you'll notice that the constructor is private. So that itself kind of implies that, well, I can never create or instantiate a file system object here if the constructor is private. It's not allowed to be called. So that's the real first magic part of the pattern when we implement this. Now, how do we actually use this? Because we do need a file system, we just need exactly one. Well, the trick for this is we'll have a function here. It's called the function name is called instance with the lowercase I here. And what this function does is it returns us exactly the one instance of our file system that we're allowed to have. Okay, so how does this work in sort of C++ terms? If we look at the code here, we say, well, if this instance variable that's down here is null, so that means it hasn't been allocated, and it's a pointer to this data, that means create the new file system. Okay, and then otherwise, if it has already been created, right, so this won't be null, then we just return that instance here. So we return this pointer here, so instance, right, it's a file system pointer here. I'm dereferencing it here because that says, hey, give me the actual file system object, not the pointer, but give me back the actual object here from this function. And that's why you see file system with the ampersand after it. And that's reference, right? That's saying, hey, refer to the actual instance here that we're dereferencing. Okay. So let me, does that make sense for folks who are watching this? The idea here? I see some head shakes, yeah. And you're going to have a chance to implement this a couple ways if it's not super clear. Again, the key here is where I see folks get tripped up is why is there the ampersand after file system? Well, that's because this is a reference, right? It's referring to an actual object, not a pointer, right? And we're dereferencing a pointer, which says, hey, give us the actual object. Right, because we want our one and exactly one instance of our file system. The other sort of C++ thing that I see folks get tripped up on, but I think you've seen in other languages, is this word static. And static basically just means this function here can only include variables that are static in it. And here's a static variable. And what's it mean if a variable is static here, this member variable here, that's part of this class? Well, that means that this instance here, with a little underscore after it, is shared amongst every possible instance of a file system. So that's the idea. So static makes this this function callable outside of the class because we can access it with essentially shared data here with the static here. So that's the idea. Okay, so again, we just hold on to this one instance of our file system, and that's the idea. And then this is only initialized exactly one time. The first time we call it when we see that, hey, we've never called this before, our instance is null. So then we'll create a new file system and return that instance to us. Okay, so that's the basic idea. So in practice, how we actually use this function here for our file system, we do file system : instance. So again, just reviewing the C++, if you're refreshing on that, the instance function is found within the scope of file system, right? That's this class. And then we are actually calling some method here, okay, from our instance. Now, depending on if this is returning a pointer, in this case, it's returning a reference. So this could actually just be instance dot here. Let me correct that just so we're clear here. In this case, okay. So hopefully that makes sense, or we'll see it a few times. Any questions on this here? So again, the key with the singleton is we're just saying, hey, we only get one of these file systems. We never have to create one because that'll happen or be managed in this instance function. And when we do want to use it, we just call, dot and then whatever the method is. You can imagine I have some other method down here called some method that's actually called. That's the idea. Does that make sense for folks? Yep. All right, great. Now just some more little aside on C++. Another way you could create a singleton, and here's another example, is to just create that actual pointer if you don't want to store it as a member variable within instance here. So I have a static variable, right? Because I can have static variables within static member functions, and then just initialize it here. And C++ guarantees that this will only be called one time. So you don't have to keep doing that, check to see if this pointer is null or anything like that. So it's a little bit more efficient potentially if you do it this way. Although I will say static variables have their own cost, but this is how we can do singleton. All right. So what's the advantage of this singleton here? Well, again, we only initialize it if we use it. That's kind of nice. That's why in this, if I go back to this implementation, we have this sort of lazy implementation, as I'll call. And the singleton, it seems to do its job, right? It has exactly one instance of the class, so something that we want only one of, like a file system. And that's great. And then we can still, inherit or derive other classes from it, just as we normally would. And maybe we would want to do this to define the behaviors that might be specific to, PlayStation or Nintendo or whatever. So that's the idea. So those are some of the pros, right? It does its job as promised, but what do folks think might be some of the disadvantages of singleton here? Or maybe you've seen this pattern and know some that you want to shout out.
Yeah, I actually read the chapter in the book, so it says something like it encourages coupling.
Yeah, right. So we're coupled, right? Anywhere we use this class, if we use it in other classes, we say they sort of live together. So it can be hard to kind of refactor out. Yep. What else did folks, anybody who read or might want to take a guess?
It might causing the race condition. Since it's global, if you use the multi-threading, then if you access one variable here, that may cause the race condition.
Yep. Yeah, so we've got one global point that everybody's sharing this resource. So if we're not careful and we have multiple threads that are both accessing a resource at the same time, that can cause race condition. And I guess we can prevent the race condition, but that's sort of a bottleneck too, right? We might have to use a lock or something for it. So that could be expensive. Anything else? I think those are pretty good examples. Just in general, having global variables can hurt our performance because there's a little bit of an issue here with locality, and we'll talk or get to the performance again at a later date. But we're sort of from a memory standpoint, it's not as efficient as it could be, especially if we have lots of globals scattered throughout our code. It also makes it kind of hard to reason about our code if we have tons of these singletons and trying to figure out, when they should be used, or if our code, as mentioned, is very coupled, which is this third point here. And that's probably a big problem. And then, as you folks already mentioned, concurrency can become quite difficult, right, to figure out our accesses. Okay. And this is the excerpt from the book here. on just encouraging coupling. So I'll let you read this on your own time. But right, this sort of breaks some of the point of what we learned about in Java or C++ or other object-oriented languages, right? To have encapsulation and information hiding, we lose that. So, the other thing that we have to think about too with our singleton is whether or not we want to allocate memory at all. In general, I'm going to push us as we start talking about allocations to avoid doing any sort of memory allocation. This wasn't a big cost in this example, but just something to be aware of. Okay. And here's a fix to that last point on avoiding memory allocation. Right? We can initialize right away our class. I'm going to skip over that. So, we're going to take a look at a lot of these design patterns from this book, and they're all going to come with their pros and cons. So we'll kind of have to choose carefully what we want to use. The reality is singleton is used a lot in game programming to solve this problem of a resource manager, but we can probably limit our usage or constrain it in a reasonable way to both make maybe our development easier and more performant, but not trap ourselves with some of these issues of concurrency. So we will have to think about this a little bit. And here's just another example if you want to encode of a singleton. Okay, so something that you might be doing similar to today, and again, just showing how to use it with some member function. All right, so that's singleton there. And here's a full video if you want to see how to build one from scratch. Again, plenty of resources, the Game Programming Patterns book or this lesson if you like. So, in talking about singleton, if I go back here to this class, we do have to think about, it's interesting enough to just create a singleton. What's it actually doing? What's its actually job? Well, revisiting our problem here with our, game engine file manager or our resource manager or whatever, the main reason, we have this is, well, let's say data or the manager is going to need some data structure to actually store our resources that we load. So we do have to think about our data structures. Folks shouted out HashMap earlier, and I think that was a good one. But we do have a bunch available to us in C++ here that we'll want to take a look at. So just briefly, part of the standard template library, these are the data structures built into C++. There's actually been a bunch more added if you want to use C++ 20 or 23. If your compiler supports it, that's fine. But you get all your basics, your stacks, your queues, decks, vectors, which are dynamic arrays, and so on, built into the language. Okay, and they have all the fundamental operations like insert, remove, sequential access, random access, finding data, sorting data, and so on, built in. So we don't have to build that stuff from scratch, at least initially here. So there is one note here, in C++, and I would still encourage this even in this class for game engines. It's up for debate in the game engine world, I suppose, but using iterators is generally a good practice. If you're not familiar with iterators, there's an example here, but it's basically a way to do a for loop, but you're using an object to iterate through your data structure. So you create this thing, demonstrated at line 11. You can look at this example a little bit later. Actually, I'll just open it up here so I can make it a little bit bigger for you on the screen. But the basic idea is that you're using this iterator object here, which is essentially a pointer, and says, hey, my vector here, I want to start at the beginning. So your intent is very clear. And then for my iterator, while it's not at the end, move the iterator forward. And this has a deterministic way of moving the iterator forward. So I would encourage that style for your data structures. This is doing effectively the same thing with a for loop. Well, this code's doing adding to a collection versus just looking through it. But again, that's effectively the same idea. So I would encourage it when possible. This also always comes up whenever I teach this class, because somebody will notice and ask about this. In fact, some folks already have. But does anybody in our live audience here know about plus IT versus IT plus plus? Pre versus post increment? Which one's faster?
Faster. So
Okay, now.
is faster.
Which one was it?
Plus P is faster.
Yeah. Do we know why?
I think when you use P++, it actually stores the value first and then increment and then returns the stored value. Yep,
exactly. That's exactly it. And we can actually look at it. This is a good skill to have, and especially if you do C, C++, or any systems programming. You can actually do the little example. Let's see, I don't think I linked it in here, but I can craft it up fast enough here. This is a tool called Compiler Explorer. It'll show you, I have to choose the right language here. Let's find C++ here. There it is. You could choose your compiler, etc. And let's make this a little bit bigger here so you can see. And if you just go ahead and, here's our hello world. Let's create some number. And the difference between plus number and number plus. Not going to ask you to read assembly code or to write assembly code. I guess reading it's pretty valuable. But usually, and let's see if GCC helps us out here. Otherwise, I've got a screenshot. Let's see. Let's turn off all of our optimizations here. And I guess it's I gotta kind of hack it a little bit. So maybe I'll just have to show it here. It ends up being one less store operation for us. At least when you're doing assignment here. Now I guess I can't see it here as much as I wanted to hack it together, but I'll just have to make this slide bigger for you. Here we are. And then you'll actually be able to see one less. Depends on the operation too, but the idea, if you could kind of match the color with plus versus some number plus to the post increment, there's one less storage that's taking place here. You'll notice in the red here, which is the second one, post increment, it's doing one extra. LEA is load effective address, so there's got to be one extra load, as you mentioned, because we've modified the result here. So that's the difference. Most good compilers will just change it for you, which is kind of the issue that I'm having here in this live example, right? This is a good compiler. Let's see if we choose like an older version, what it does for us. It can try to break it. Nope, I guess GCC's always had this, or maybe for a while. But anyway, that's the idea here. There's no side effects. That might actually just be getting rid of this code anyway. But that's the idea. So just a little note there. All right. So anyway, without going down the rabbit hole of optimization, your other data structures, linked lists, again, efficient for prepending or pending nodes. So you might want to think about where you might want to use linked list. This is effectively what it is. It's a generic data structure. And something to keep in mind with our linked lists is whether they're extrusive lists or intrusive lists. So what does this mean? Well, again, you've probably heard of linked lists, this data structure, right, or used it. I'm imagining everyone in this class. I don't know if you've seen the distinguishment between extrusive or intrusive. And let me make this just a little bit more clear so you can see here. The bullet points help a little bit there. Extrusive list is if the elements can be shared amongst other lists. And then when you have intrusive, which is what you're probably more familiar with. That's what this example is. The elements are unique to this list here, right? They're stored inside of the actual list here. So there's different sort of pros and cons. I'm guessing most of the time when you've implemented a linked list, you've done it like this, where you have the link or the node data structure, and the next or the previous node also stores the element. And that's sort of nice in a way, because as you iterate through this, the data is right where you need it to be. But you might want to be able to share and have a separate element list that's created that you point to. So that's just the distinguishment between those two. And I'll have to revisit this a little bit later when I talk about caching, but there's an implication on caching that could be important. So that's just a little bit on linked list. The important one for you to know about today, since we're talking about our resource manager, is hash tables. Again, hash table, associative array, map, unordered map, dictionary, all the same sort of things in this class, or same meanings. And what I really want you to look at for today is the unordered map. But really quick, while I have folks, does anybody know the difference between unordered map and map in C++? There's actually two structures. Yeah, if we don't know, let's do a little bit of an investigation here. Well, we can search this link here. I actually like, let's Google it and go to cppreference.com. That's my favorite website. Actually, let me just show you the front of the website, because there are a bunch of new data structures and stuff that you can use. So feel free to check these out. But again, let's get back to unordered map. So I'll click on that one. And let's see here. Okay, unordered map. It's an associative container. So that means it has key and value pairs, just like a hash table, or however you've learned it in other languages. If we kind of scroll through this, let's see if there's some useful notes here. Right, here's all the different operations. Somewhere it's going to define the complexity for us. Let's see if I can find it here. Might not say in this documentation here. Let's see if we go to the unordered map header. Sometimes you have to actually just click on the actual operation. So if I scroll down here, let's say insert. That's probably reasonable. Somewhere it'll actually give us the big O. Should for each of these. Let's see. Big O is kind of, here it is, complexity. Okay, so for inserting into an unordered map, and the average case, we're getting O of 1, so constant time. Let me zoom in on that here. Oh, there we are. So that's good news. What about if we look at map? I think it's got the same operations. I'm just going to change it in the URL. So this is map here. Okay. And we scroll down, look for complexity. Okay, in the worst case, log of its size. Okay, so that's probably worse. Maybe it's more guaranteed or more steady, but typically we prefer constant time operations in our algorithms versus logarithmic. So there's a difference between map and unordered map. I've just kind of pushed you towards unordered map. Unordered map is an array-based data structure, and map in C++ is a tree-based data structure. So that's something you can kind of keep in mind. So you usually get, then there's some other properties too, as far as, are elements guaranteed to be ordered? Well, in an unordered map, they're not. It says unordered. So that's the idea. But anyway, this is a good data structure for having a key and a value pair for you to think about. Any questions on unordered map, or if you want to call them, hash tables? That's fine. Yeah. All right. So just a few other things to be aware of in C++ land. Does anybody know how strings are implemented? or how would you implement a string if you were going to write your own string class in C++?
An array of characters.
Array of characters. Yep, that's it. That's what folks do in C++. Right, it's just an array of characters. Now, it turns out string, is built on top of, or it implements an interface for something called basic string, which is an array of characters. There are some issues that we still would want to think about, and at some point I'll have you think about them, but not all characters are just 1 byte, so your underlying char data structure matters, right? Depending on the language or the Unicode character, it might be 2 bytes or 1 byte. So we have to think about that a little bit. Again, thinking about games as a global industry, right? And we want our games to be played on not just U.S. or Canadian-based systems. We want them everywhere. So good note there. So again, algorithmically, a few things or properties about strings. It takes time to compare strings. There are some, maybe bit tricks you can do, but typically you have to do some kind of character by character comparison. So you have functions like string compare or string copy to do this. And think about things. So there's a few other optimizations we can also think about, but I'm gonna just, for the most part in this class, we can rely on equals equal operator or string compare. All right, so that's just a quick little summary of the standard template library. We want to take advantage of these data structures that are built. We don't want anybody, at least at this point, building their own map. I mean, you're welcome to, but you can save yourself time maybe after you complete the assignment. So that's the STL. There is the Boost library, which is also popular and has a lot of other C++ data structures that are useful. The reality is most of the Boost library, as far as data structures, just kind of get incorporated in the STL after some amount of time. So that's something to keep in mind. So there is a little experiment that I will ask folks to run as part of your in-class activity when we get to that portion towards the end of class. But if you go into the repository for building game engines, and you can do this later, right? So that's just in this commented code sample. We're in module number 3 in this locality example, which I'll actually take a look at here. I've got some code here, and the basic setup is you're just going to do a little performance example with linked list versus an array-based data structure. And I'll actually just show you. You're setting up your linked list, doing some operation here to add some elements to the linked list, doing something similar for the array, and then this program will tell you which one's faster by just timing them. So less time or lower numbers, better. That's the idea of the little experiment you can play around with. So again, just keying in on these data structures matter, our choices. The last sort of note I'll give folks on this is on reinventing the wheel, as they call it, so rebuilding something that's already been built. Game engines very often do reinvent data structures, and that's distinguishing the purpose of the standard template library, so standard or general purpose. We want to build a library that's useful for games. That's what we care about. So it's very, very common at game studios to re-implement map or unordered map and string and all these data types. So you might consider, again, if you finish the assignments early or just curious, looking at Electronic Arts standard template library here. They released it a few years ago. Somewhere in here, there's actually a really nice rationale. It's a little bit of a read, but it's quite nice if you want to read it. And there's been some other companies that kind of copied or followed along, like Facebook released their standard library, right? So folks re-implement this, but you can kind of see, if you dig around the source, what data structures might be important, right? There's an intrusive list, and they have a red-black tree and these sorts of things. So what data structures do folks actually use? How do they create them? Also a nice way to learn some C++. There's a tiny chance if folks really push for it and keep encouraging me, we would use the EA standard template library in this course. I just need to see how debuggable it is before we commit to that. But that might actually be a good experience to try to use those data structures and build that library. And again, the purpose is, if you build your own data structures, you've got full control. You can debug things. You don't have to make it a templated library if you don't want to, which has some advantages. There's usually more room for optimization. And I also like eliminating any dependencies, right? I like having all the code. We're building pretty much everything from scratch in this course. So that's just a note there. So any questions about standard template library or data structure stuff as we look at that? Anybody in Vancouver definitely want to look at this and say, we should use this? Well, think about it. Maybe take a look at it. It's kind of nice, to see what folks are working on, in industry as far as libraries and stuff. Let's see. I'm going to push this forward a little bit, and then we'll take another break in a moment. But just more on the importance of our resource management. I've kind of gotten through what a resource manager is, a singleton class, and then what data structures might be useful for us. But again, I want to emphasize that sometimes when we're loading one image, it's not really just one image. It's a full, what we'll call a sprite sheet. So a collection of images. So many of you folks might recognize that this is Mario, the famous Italian plumber, I guess, from Nintendo. But the idea is when we load this image, again, it's consisting of, 20 or 30 or so Marios here. So, if I have 2 of these characters in a game, I don't want to reload all of this data. So it becomes quite expensive if we're inefficient here. So the same follows with our 3D data or whatever, that we want to be efficient here. So, keeping this in mind, and for today's sample, you are going to load an entire sprite sheet like this and animate it. So I got to give you a little bit of an introduction to what that means. What's a sprite? If you haven't heard this word, well, a sprite is just some 2D entity. So like Mario, our Italian plumber here, that can be sort of repositioned, right? So it's just a texture on a rectangle. That's a sprite. And if you play the images in the right order, right, you can have Mario move around or basically cycle through the different pieces of that image. See here. Okay, so Mario is animating as we cycle through things. You can get as detailed as you want with sprite animation. I thought this was just a really beautiful one made about almost 10 years ago, but still holds up. Disney style animator made this. But the point of sprite sheets, here we are again. So usually hand drawn. That's still true these days. Is you divide up this sprite sheet into equal segments here. So it's essentially a grid here, something like this. And it could be left to right or top down or whatever. But let's just kind of divide it up this way into equal size grid, or roughly equal as I could draw in PowerPoint. But here's frame 1. If we sort of access this rectangular region, frame 2, 3, 4, 5, 6, etc. Right? So we just sort of have them identified as we move through this smaller region of this larger image. So the idea might be that the first 6 frames or first 6 chunks of this image make up a jump cycle. And you can kind of look through this, that if I play frames 1, 2, 3, 4, 5, 6, you can kind of see Mario standing and then eventually in this sort of jump position. Okay, and that's like a flip book, or that's the actual animation here. So that's the idea. Okay. So in order for us to get animation into SDL, right? There's no load sprite sheet or any of these sort of functions. We have to, sort of do this process manually, meaning figuring out how big each of these boxes are and how to proceed through our image. Okay. And you can have big sprite sheets or little ones, so we need some way to cut up this sprite sheet. For the most part, the sprites that we'll work with in this class will just be an equal grid and kind of makes things easy. But as you'll observe towards the right of this image, you can see how a sprite can be broken up into different chunks where you just have the character head and you might want to mix and match to create different entities here. That's totally possible. So there's tools for this. Unity has a lot of tools that we might want to emulate for creating sprites and selecting, the region of each sprite. And again, little tools to preview the animation. Historically, I've had folks build a little animator like this as well. So we will look into some tooling. So here's what I've provided for you today. Does anybody know where this character is from? What game?
It's a game where you can travel through time, I think.
Yeah. This is Braid. The game is probably 10 or so plus years old at this point. By Jonathan Blow. And it's a time traveling game, but here's the main character. Found a sprite sheet. I think we can use it for educational purposes here. Here's the idea. Again, we have this, if you look at the first row here at the characters, this makes up a run. That's what I'm playing here in our SDL program. Now, what you'll observe, though, is that there's 50 of these characters running here. So, one after the other here. 50 is just an arbitrary number. You can change it to whatever you want, but 50 of these running sprite sheets. So that's what we're working with. And if you want, you can cycle through the rest of these, the rest of the run cycle, and it'll be a little bit smoother. But there is a catch, of course, here with getting this all to work, that I have a problem. And I won't say what it's not a lab, it's a full assignment. This is your assignment 3. Is that if I want to have, again, these 50 characters in my game, what I've done naively is I've just loaded this image 50 times here. So this, bitmap image. And then I'm doing this sort of same work of dividing or setting up this animation 50 times. It's a lot of extra allocations, right? I'm creating the image 50 times, waiting to load the image 50 times, creating the texture 50 times. You get the idea here, right? So your actual program is going to print out something like this. The SDL bitmap was allocated, then the texture was allocated, then the bitmap was allocated, then the texture, for each of these 50 instances here. If you count it up, what is this about half a megabyte file actually ends up taking 26 megabytes. So again, 50 times the amount of space that it should take. Okay, so this is again the importance of our resource manager. Being able to avoid this waste here on both, and that's just on the CPU. We're wasting the same amount of memory on our GPU as well. All right, so the problem that we're going to work on for our assignment is to again build this resource manager. And basically what we want it to be able to do is to store pointers to some resource that we have. In this case, I'll ask you to store at least the resource for the bitmap, the SDL surface pixels. Okay, that's the idea. We are actually still going to be a little bit wasteful, and you can add in your assignment 3 to store the textures, but at least have one resource manager. Okay. All right. So with that said, we'll take a break here in a moment, but I want to go ahead and just run the assignment so you can see what's going on here. So you should have, whenever you do git pull, your assignment 3. I'll go ahead in here. You have 2 parts. I'll talk about part 0 at the end, what you'll be doing, but that's just an exercise for you. But let's go ahead and again, I'll run this. You can see everything allocated. There it is running in action. Just playing the first 6 frames. You can play more frames if you want. You can use a different image if you want to. It's fine. But again, just looking at the code here, let's go ahead into let me go ahead and orient you a little bit. So what you'll have is, well, I included a few other sprite sheets if you want, but you'll have your resource manager. All right, so the header and the associated implementation, and then your sprite class. Those are really the important things. So if I look at the sprite class here, which is here, the actual implementation, you'll see a few to-do notes, and hopefully immediately you'll, or after thinking about this a little bit in notes, you'll see the waste here. And every time I create this sprite, I'm again going through and doing load bitmap, checking if it was loaded, and then creating a texture from this bitmap. So the very least we can do for this assignment, and again, what I'm asking for is for this process, if we've already loaded the pixels that we need, this pointer, we should just be able to say, hey, sprite sheet equals get resource from resource manager, and then create the texture for it. That's basically the idea. So none of this code should really exist in our sprite, right? Our sprite is just an image or a texture that we move around. It shouldn't be responsible for working with the file system and creating the texture and so on. So again, it's sort of a nicer architecture to move this stuff into instead our resource manager. Okay. All right, so you'll need to think about how you fix this, right? You can see, yucky, this is bad. Some ways that we can improve things. Okay, so I have some way to load a resource and get a resource, maybe based off of that resource name. Okay, so that's the goal here. Any questions about what you'll be trying to achieve there then with that code? All right. If let's go ahead and take, we've got one or so more sections that I want to talk about here. Let's go ahead and take another 10-minute break here. And then we'll pick up from there to our grand finale, and then we'll shift into letting you folks work for a bit.
Hey, Mike, can I ask you a question about assignment 2?
Sure, go for it.
So for assignment 2, part 0, task 4 is asking us about STL abstraction. So I'd like to know what is the abstraction that you're talking about? Is it a low-level STL structure we have for building the game, or is this something about our game loop, anything like that?
Let's see here. This is part 0.
Maybe go down to task 4. You'll see it.
Task 4, yeah. All right, let's see here. Could be improved. Let's see here. Let me try to be clear. STL abstraction. Frame capping. I think, let's see here. I guess I didn't give you something explicit to critique here. More just a thought on the actual API as far as, do you think the functions are organized in a reasonable way, to give us access to loading images, loading textures? Could it be improved? Would it be better if it was object-oriented? Is it clean enough as an API as it is that it's fine? That's sort of the basic idea. Just kind of what do you think about STL, and to think about the design.
I see. Okay, yep. Thank you.
Yeah.
话多了。给他
商标的问题。
西西还能吃。
Yes, well, yeah, I think you did like it too. Pardon?
Did you like midweek? No, I think it is like all next week.
Oh,
In
yeah,
some-
yeah, exactly. I'm just letting it go.
TTF 搞定了吗？TTF 你装完了吗？
好丑。
挺好的嘛，可以，牛逼。他应该早就可以玩了吧？不过没有技术版，但是画不出来那个图。
画个也没行。好像一个抓球。
球呢？
抓球。
球呢？
我都没看到，哦，no，看到了，
这里
看到了。
微血太小了。
可以发个球。
你怎么不用它那个自带的？是这样。OK， 牛逼。
一个差
点。别看他吹，别看他吹，别看他吹，我这随便加一点 menu 而已。别看他吹。
我本来都打算解课，解义了，解这个中间。
解呀，你跟我比啥呀？你跟我比啥呀？然后我要跟老师对待 structure 到底要怎么写，你还没想好。我还不会用。
这个是我学习的。是我的学习方面。
留下来做作业吧，做作业吧。
看我电脑。
什么时候到？下个礼拜。
下个月。
那你可以用这样怎么办？我把我那个点，我那个电脑是有差评。到时候如果到时候确实在我家的话，我就可以借你一部笔记本，然后我用我的那个主机。哦对，那个具体的配置可以再聊。
手机打过来。
是这里。 可以这样长一点。脖子是哪个？这个脖子是那个，这不多。你要我死吗？这太多了吧？这不会是那个蛋糕吧？不是那个东西。哇！
那个 in-class activity 得忘做。
皮卡是不是 job 了？哦，上个世纪。这样。
All right, folks, come back in action here. Good to see everybody. And we'll do the final kind of stretch here. So any questions before we proceed forward about, what we've been working on and what our sort of goal is with this resource manager? Hopefully clear. Yeah, all right. All right, so let's see, we talked about the usage here. And let's see, our problem that we've solved here. Okay, so just a little bit on the actual usage, which we've mentioned, the job of the resource manager to load and unload resources. And again, just to make sure that each resource is unique. For part two, and make use of a data structure to help us with that. I think the important part too is that we're through the resource manager to really determine the lifetime of each image that we load or texture. Okay, so this is going to get into a little bit of a theme for this last part here, that we want control when we delete something, not necessarily when an object's destructor is called or any of these type of things. So as mentioned, you can look at the resource manager for some singleton examples. That's probably the right pattern to be using, again, at least for now. We might want to think about how we can improve it, or maybe use some other combination of patterns for testing, but we can kind of refactor that out later as needed. So again, we need some sort of data structure. You'll have to think about what that looks like. Or maybe not so much, since I've given some enough hints on the unordered map. But at least think about what your key value pairs are, and you'll see that in the assignment. At least for handling SDL surfaces. All right, so just to give you a brief walkthrough of the code, some of the important parts. Again, for your goal is, and I showed this prior to the break, but it is to modify the actual sprite sheet. Or the sprite class, and get rid of all this code where you're loading resources, for the bitmap image and the texture here. We should really just be, able to look at what the sprite sheet is, do a lookup, and then create the texture from that. Actually, we might need to still create our texture here if we only have one resource manager. But and again, that'll save us, and you can actually measure this on your system and your task manager, but it should save you, 20 or so megabytes of memory. All right. Now, if you want, you're also welcome to do a little bit more with the sprite update functions. As it stands right now, it's just playing the animation the first 6 frames. And as I mentioned, I've included some nicer sprite sheets if you want to play around with those and kind of figure out the size or the width and the height of the window, you're welcome to. It's not part of this assignment, but in the future, we might do a little bit more with the animation system. Certainly for your final project, you might want to consider that. So, you can invest some time into that now if you'd like. And this came up during office hours every once in a while, so you can read this later. But just if your sprites are playing too fast or too slow, for this lab or assignment, rather, I should say, I'm not giving you any of the frame capping or that type of code. So there's just an SDL delay in there to slow things down, right? And you've done or doing the frame capping for your homework. Anyway, so here's some of the data structures you can look at and choose from. So just kind of keep those in mind. So that's your primary goal for the assignment. I'll talk about the other goal in a moment. But before we get to that, what I want to talk about is various support systems. And of course, I mean, supporting each other and, being good friends and stuff. But yeah, I mean this from a engines programming task, actually. So, help each other out, in terms of, answer Piazza questions and stuff and ask questions. But what I really mean with support system is engine support systems. And this has to do with the things like, initializing and shutting down a subsystem. We've seen this with SDL, for instance, where we initialize SDL and then we call SDL quit when we're done with it. But this also has to deal with other things like managing our memory, working with various data structures or configuration files and so on. These sort of crucial tasks here, to set up, all these important systems, okay? Usually when we think about games, whether 2D or 3D, we think about this. We think about the graphics, but we don't think about all the behind-the-scenes systems, which is what an engine programmer is doing, right? You might be doing graphics work as well, but we are thinking about memory, data structures, these types of things. Equally as interesting. From Jason Gregory, who's the engine programmer of the Game Engine Engine Architecture book, he talks about all these different systems. He says, they're the mundane things, but I think they're interesting as a systems person. Anyways, but all the different little things that we have to manage, logging systems and file access, the resource manager. I think they're kind of cool when we get things working. But one of the patterns, again, that's maybe going to go against things that you've learned in other courses is sort of this pattern of what we got to call initialization and a shutdown pattern. And what does this mean here? Well, let me ask you folks again, what do you think in C++ or Java whenever I say initialization and shutdown? What comes to mind?
Constructor and deconstructor.
Yeah, constructor, destructor. That's exactly right? Classes, right? And we've looked at this a little bit, or maybe the main function, maybe new and delete or these types of things, but we don't call them initialization or shutdown typically. Other APIs maybe, but what this means is, or what I'm getting at is, in C++, we don't really have control over how our object's constructed or destroyed. We do know when it goes out of scope, it's destroyed in a deterministic order. We do know when it's created that it must be created before we can, call functions on it. But that's about as much as we know or have control of, which is totally reasonable, right? And of course, there's scenarios we can call delete on something that's heap allocated whenever we want, but we might have some longer running systems. So this example is showing where we have a graphics subsystem, physics, audio, collision, etc. where we might need to restart those systems or shut them down explicitly or pause them, right? We want a little bit of control over how these things work here, right? So if you actually run this snippet, which is included, you can see the order that the constructors and destructors are called, right? It works in a stack manner, right? Last in, first out. So last object you created was the first destructor that's called. But sometimes, again, you might need to reset a system, whether it's for debugging purposes, like maybe the artificial intelligence has stopped the game, or you have to press restart. We do this all the time when you're playing a game, but probably don't think about it. So it could be an option to just say, hey, start from scratch, turn off everything, but and just go restart from scratch essentially. But what if you do have a game system that's long running, right, for hours and hours and hours, and there's a glitch or something, or even just for development purpose? We want a little bit of control here. So the solution that we have, and that's typically used for a lot of folks, is to just write the .startup function and then call .shutdown. Because it could be that there's actually dependencies on some of these systems on each other. Or, for example, if you make a change in the video system, the change the resolution, you need to reload the graphic system or whatever, and you might want to be able to do that in game. Okay, change the resolution, change if it's using Direct3D versus OpenGL, or all these sort of little settings without having to restart your computer. So that's the idea here with this pattern. Again, it's a little bit weird. Again, if we're used to constructors and destructors, it's giving us control at the cost of we have to maintain this system. Right, so that's the idea here. And we've already seen this, right? This is a very C programming pattern, right, where we have, again, SDL initialize, SDL quit, and that's the idea, right? Some engines will even sort of go to extremes where if you have all these subsystems, that you want to use, you push them into a queue, and then the priority queue or something will figure out the exact order to initialize them. But the point is you have that control over your game engine. So I personally like this approach, and it tends to work well, again, when there's no inheritance or complicated hierarchies, which we want to tend to avoid anyways, at least as far as some of these systems go. But again, it gives us the option to restart and reset systems while our games are actually playing here. So that's just the idea here. So you'll see that occasionally pop up. It might be an anti-pattern in other courses or something, but it's just game engine programmers do stuff a little bit different, right? We're looking at actual game engine code here. That's just how it goes. So with that in mind, as we kind of wrap up here, it is worth looking at some actual code just to see, that these things exist. The starting up how to structure some of these subsystems as we're thinking about this, alongside our resource manager that's managing some of the graphics stuff. So Ogre 3D is a pretty nice graphics framework that's open source and has some nice code snippets. So on occasion, we'll look at some real code. I think that's very important. I mean, all the code's real, right? We're writing from scratch, but just to actually see how things are done here. So as far as Ogre goes, here's part of their engine here. You can see, they have a render system here, and they have all sorts of manager classes for managing the scene, the camera, libraries, geometry, and so on down here. So you can, take a look at this as you need here. They have an actual interface that they've created for singletons where needed. So again, for better or for worse, this code is quite coupled, and you have to use it, but that's okay sometimes. We just have to know what we're doing here. So here's all the singletons. Now you'll notice that all of these singletons, and this is something I'll comment on. You'll see my note in the assignment that it might be okay if we have all the singletons sort of together or encapsulated themselves as simple objects in one singleton. That's another way to kind of get away around things. So anyway, and then here's just sort of the startup and initialize pattern, right? We sort of create an object and then we explicitly initialize it when we're ready. Okay. So that's the idea. All right. And if you want to see the Ochre engine in action, there's a little video here. It's a nice engine for folks again to look at here. All right. So any questions, concerns, or comments on this sort of idea here as we're wrapping things up? Nope. All right. So a few things. Then I'll show you your assignment, and then we can have some Q&A if we need. Hopefully we're motivated again by this idea of a resource manager for efficiency of space. It'll speed up, how fast our game runs. It's going to reduce pressure on our memory systems and so on. Even thinking about eventually loading data from an archive, that's going to be better for even security or leaking out our, valuable art assets. So a lot to think about there. And then hopefully, for folks who haven't seen sprite animation, this is a nice introduction just so you understand what's going on there, and we can draw some cooler scenes. And then we've also learned about this sort of couple patterns, right? The singleton and the sort of startup shutdown pattern that we have here. So going forward, you have your in-class activity, and then I'll just show you the last note here about your homework. You're also going to be doing some debugging exercise here. So to assignment 3, which one should have. Let me pop this open. You've got the part 1. That's all about the resource manager. So make sure you take a look at that. But part 0 is to again, depending on your level of comfort with C++. So I've got this exercise. If folks have graphics or C++, it's similar, but I've changed it just a tiny bit. But basically, I want you to get used to using a debugger like GDB. And what do I mean by this? Well, the best way is to actually, I'll let you read this on your own time so you can see the why, the sort of videos, the commands, but I think it's probably just nice to show you. If I go into our mono repo, the first thing to show you is, as I make this a little bit bigger here, let's go into assignment 3 and actually debug it. I've started doing this thing that's a little bit sneaky, but every time you compile your program, you're actually compiling it with debugging symbols here. So you'll see a little -G here. So you should see that, by default. Even, let's see, the Mac folks, I think, should have -G somewhere. Or I guess the compiler is the same in all these, so it doesn't matter. But Windows, yeah, there's a -G. And that compiles your program with debugging symbols. So you can get some extra input out when you run the program. Okay, so let's go ahead and build your assignment 3 part 1 this code. And then if I, again, just run this, it runs, which is fine. And then you might be trying to figure out, well, what's going on at all. So a great way to understand what's going on is to run through a debugger. So with GDB, you can run your lab here and sort of step through the program. These are the exercises you're going to do, so I'm going through them a little quick, but you start, and then you can kind of see what line we're on and list out, the actual code. So you say, oh, here's the main function here. Okay, so that's the idea here. This isn't quite helpful enough, though. So GDB has a text user interface, which you can see. So you can actually kind of step through this program. Right? So I can type in next, go to the next line of code. It says, oh, wait, I'm doing something, weird here. DL catch. OK, I don't know what that is. So I type finish, enter a few times. Let's see where we actually are in our code. It's executing. It's basically loading up SDL at this point here. Let's see here. What happened here? Keep going. OK, eventually, if I hit enter enough times, I'll get my window to show up. I can kind of see where we are in the code. Again, I'm still just typing in finish and then enter a bunch of times. Ah, there we are. Okay, so we're inside one of our functions here. I can type in next, go to the next line, next, next, Control L, let's see, next. Here I am inside my loop. So I could do next or step into this code and kind of see what's going on here. Okay, next. Okay, so printed out a bunch of stuff here, doing my allocations. Let's see, next. Okay, so I'm doing something with handling text. I mean, you kind of get the idea, but the point is I don't have to put in a bunch of print statements. I can just type out print, and what's the value of quit? Oh, it's false here, okay? Or I could say print E. What's E? Well, if I look at line 101, that's SDL event here. So let's print that out, and you can see all the different things going on with whatever that event is. So you can actually print out an entire structure. That's probably too much for us, so let's move a few more lines. Next, next. Now let's try to print out E and see if anything interesting happened, or E dot type, because that's the thing we're comparing here. It says 4352. Okay, well, I don't know what that is, but I could actually grep for it or something. But that's sort of the idea here. Handle some events, next. Now one of the tricky things is here is as I hit enter, it's capturing those events. So I need to break out of here. So let's advance to line 116. Okay, so I made it out. Go next, next, step into the renderer. And we can see the different rendering things that we're doing here. Next, how many sprites do I have? Print M sprites. I'll hit tab, I can autocomplete, size. Okay, there's 50 of them. So anyway, you get the idea of how this debugging works. And you can do it, using GDB. That's the materials that I'm going to supply with you folks. Now, a lot of you folks might also be preferring to use a integrated development environment. That's totally fine. If you find GDB with VS Code or LLDB is the other debugger, or you're using CLine or IntelliJ or whatever, I don't care. The point is that I want you to capture a screenshot of you debugging so that I know you can kind of step through your code. Because this is exactly what I do with you in office hours. This is how I can usually figure out what you folks are doing, with 100 different code bases roughly, relatively quick. So it's a super skill to have. You have to have it as an engine programmer. So I'd like you to do it. That's why it's part of your homework. So some of you, again, might be pros with this, and in that case, it'll be super easy. Some of you folks, this will be totally new, and that's fine. I just need you to know at least the basics of how to print stuff out. Well, if I just do print M sprites, that'll just show me the data structure. I can do other neat stuff like print out the type of whatever M sprites is, and that'll tell you, hey, it's this vector thing, and you get a bunch of other data about what a vector is. Again, maybe too much, but let's see. The last thing I'll show you, you can type out like info locals. That just prints out the value of all your local variables. So again, there's all sorts of neat stuff you can do, and hopefully my tutorials will help you, learn a little bit about debugging and setting, breakpoints. Let's actually do that quick. Breakpoint at line 85. Which, well, there's no code on line 85, so it'll go to 86. And then I can just hit C, which is short for continue, or type it out. And then every time I hit enter, it's just going to keep continuing and running until I hit line 86. Unless I put a breakpoint at, say, line 79. And let's just continue. And you can kind of see, as I do continue, it's just bouncing back and forth between these two breakpoints. Okay, so that's a quick way to move through my code. You could put breakpoint on loop or something too. And if you want to be specific, breakpoint at SDL graphics program loop. You'll see it was entered at line 94 if you need to take a peek, but that'll do the same thing. And then there's all sorts of stuff. Here's where my breakpoints are. Let's delete breakpoint number 2. Okay, so we don't have it anymore. Oops, delete breakpoint 2. Okay, anyway, that's the idea on GDB. So are folks clear on the exercise or what you'll be learning? Need you to learn a little bit of a debugger. That's the goal here. All right, that's GDB. Quite powerful, nice tool to have. And there's plenty of videos. Again, you can use mine as support, and then there's some other ones provided as well. So let me pause for questions for a moment. Questions? No. No questions? All right. If that's the case, go ahead and take a few moments for your in-class activity if you need. And then I'll hang around a little bit for the Vancouver folks if you have any questions that you want to ask. And then otherwise, I'll stop the recording and I'll get that posted here. So let's stop this.